All right, so in this video, we're going to be talking about multiple bonding, and I think this is the last video for chapter 12. So the goal is we want to be able to distinguish between single, double, and triple bonds and identify these differences in a Lewis diagram. Okay, so a single bond, only one electron is shared. So if I had carbon atoms here, right, this is what it would look like. Okay, so one electron is shared. And remember, each one of these lines represents shared electrons. So if I put two dots there, they're the two electrons that are shared between these carbon atoms. All right. And a double bond, then, two electron pairs are shared. So there would be two lines here, which each one of these lines represents two electrons or an electron pair. Okay. And then, of course, between a triple bond, okay, as the name suggests, there are three electron pairs that are shared. Again, which each one of these guys, 1, 2, 3, 4, 5, 6, shown here. Okay, so double and triple bonds then are what we refer to as multiple bonds. All right, so atoms between more than one element atoms bonding to more than one element. Ooh, okay. The formation of water molecule from its atoms is an example of this. So we have a hydrogen plus an oxygen plus a hydrogen. When you do that, it's H2O, right? Where we have two hydrogen atoms and one oxygen atom. And so the oxygen is actually sharing, okay, electrons with both hydrogen atoms, okay? So additional molecules with atoms bonded to two or more atoms, well, you might have something like this, methane, okay, where you have carbon bonded to 4 hydrogens, okay? Where each one of these lines, again, represent shared electrons between them. And if you notice, the carbon atom has 8 electrons around him. That's that octet rule again. Same idea here with the oxygen atom, if you were to count up all of those electrons being shared and the lone pairs around the oxygen atom. So again, these were just examples of additional molecules with atoms bonded to 2 or more atoms. Same idea here. Here's ammonia. We would have 3 hydrogens and a lone pair there, okay? So again, these are just examples that we can use to talk about this sort of thing, okay? Let's see here. Yes, okay. I was just making sure in my notes that I'm not missing anything. So again, you can have multiple bonds, which is like double and triple bonds, and also you can have atoms bonded to multiple other atoms, okay? More than one element. Okay, so here's some exceptions for kind of the whole chapter to the octet rule. If you had an odd electron molecules, so it's possible to write Lewis diagrams for odd electron molecules in which each atom is surrounded by 8 valence electrons, okay? So this is like the nitrogen here has a weird number around it. Same idea here for these two types of molecules. It has to do with their valence electrons and things like that. Just know it's out there. It's a thing that you might have these odd number of electrons. You have molecules sometimes that have more than 4 electron pairs around the central atom. Okay. You have molecules that sometimes have fewer. Excuse me, like beryllium and boron. So they can have 2 and 3 pairs of electrons respectively. So that's kind of a violation of the, octet rule. And then for oxygen, no Lewis diagram can be drawn for oxygen that matches experimental evidence about its molecular structure. So for example, liquid oxygen becomes trapped in the field of a strong magnet. So what you could do actually is go to this PowerPoint slide when I post it on Blackboard and look at this video, and you can see that actually oxygen is paramagnetic, liquid oxygen, and it'll stick to a magnet as shown here when you pour the liquid nitrogen or liquid oxygen past a magnet, but something like liquid nitrogen actually doesn't do this, meaning that oxygen has this unpaired electron. Okay, so it's just kind of weird how it behaves. So these are some exceptions that we might encounter, but definitely if you take some more chemistry classes, you're going to encounter more of this. Okay, so it's just kind of to be aware that there are exceptions to everything I just said, as if you stick around with chemistry for a very long time, you'll realize that's the case. For a lot of things, there is exceptions. But the key is, for this section, again, multiple bonds are when you have double bonds or triple bonds, which are 2 or 3 shared pairs of electrons between atoms. And then you can also have atoms bonded to multiple atoms in a system or in a molecule. Okay, so that's it for chapter 12. Hopefully that made sense. And if you have any questions, as always, feel free to ask me. I'd be happy to answer them.